the title of my talk from a short story written in 1950s by Roald Dahl. And he wrote a story about a man who invented a machine that could write stories and that eventually put all the authors in the world out of business. Now, this is not something I believe is going to happen. It's not one of my concerns. But as we get better at artificial intelligence, we begin to wonder, is there a more optimistic view of why we should be using artificial intelligence and why we should be using artificial intelligence to read and write stories? And I think one of the reasons why we're here is because over the last couple of years, we've seen amazing things happening out in the real world, out of the labs of in the companies that are implementing artificial intelligence. And in some sense, we're going through what we refer to as the machine learning renaissance, which is that things are actually starting to work the way we're hoping to work. Now, to me, machine learning is a version of artificial intelligence in which involving the automated discovery of patterns in data and then acting on those patterns to do interesting and useful things. And the reason why we're having this renaissance right now is largely because of two things. We have more access to data through primarily the internet, but also other means, and then also what I call big iron. We just have better computers, bigger computers, cloud computing, and so on and so forth. And what we're starting to see is that artificial intelligence is working in lots and lots of different domains. Although language has been one of those things that has been very difficult to come by, to make machines reason about, think about language. And one of the reasons why language has been so difficult for computers for a long period of time is because of what we call semantics, which is that words are more than just strings of letters, as we just saw. They actually have meaning to us. And those meanings can sometimes be complicated, they could be nuanced. We can manipulate those meanings in lots of interesting ways to create irony, metaphor, sarcasm, humor, so on and so forth. And so, to give you an idea of what I mean by semantics, I have a bunch of words up here. And if I were to ask you, how would you sort these? How would you put these in categories? You might pick out different words that are related in particular ways to you in the way you think about the world. So you might put them into categories like this, putting king and queen, man and woman together, animals together, and like that. Now, while this is very easy for us, for a long time, this has been very difficult for computers because they lack the ability to figure out what these semantics are. But what artificial intelligence is actually very good at doing is math. So if we can figure out how to turn semantics into math, and this is what we've been able to do, now we start to see a way forward in dealing with language technologies. So to explain what I mean by math, let's just turn to simple geometry. So here's a three-dimensional space. If I could put every single one of those words as a point in that space, so here's one word, some X, Y, Z position in this three-dimensional space, we'll call this point king. And we'll put other words up here as well. These different points, we'll just label them as different words. And once we have things in points, we also know that we can create lines from the origin. We call these things vectors, right? So at this point, if we can configure all the points in space in just the right way, we can do some really interesting things with math. So in particular, we can subtract points. So what does it mean to take king and subtract man? Gives us another point. Let's add another point to that. Let's add the vector called woman. And if we configure this space just right, then we get mappings that, to us humans, actually make sense. So how are we going to ultimately configure this space? How do we figure out the semantic mapping of words into mathematical geometric space? And this is where we've turned to things like neural nets that have really kind of become the go-to technology that we see out in the real world right now. And this is kind of a little idea of how this is going to work. I'm not going to go into a lot of details here, but basically, we start with words, and we don't know what those words mean to a computer. And what we do is we just take all the words in our language, maybe there's 100,000 words that we care about, and we just line them up in a big row, okay? We do that. It doesn't matter what order we put these words in. It could be completely random. But what we can then do is to say each one of these words we can now convert into a number by basically just saying, this is called a one-hot vector. Basically, we say we put a 1 in the position for every single word and zeros in everything else. So that means king now is the number 0001000000000. Okay, so we have 100,000 numbers like this, and they refer to all the words in English or Spanish or whatever it happens to be. And then we ask a neural network to say, take all these 100,000 words and smush them down into 1,000 words. And how is it going to do that? To smush these things down, it's going to have to figure out that it has to reuse these bytes It has to say, well, now this word is 0.7 of this and 0.5 of this and 0.1 of this. And if we do this for all these words, the neural net is going to discover that the best way to do this is to use the same bits to refer to things that tend to mean the same thing. So king will have more bits that are similar to the things that queen is more similar to. And ultimately, this mushed down vocabulary of basically 1,000 made-up words is now all of our XYZ points in that space. So now we have essentially learned the semantics in a mathematical sense of our entire language. And this is kind of what has been ultimately making the language technologies that we see out there work. And some of the most successful technologies we've seen out there is language-to-language translation. We're doing better with word search, web search. And so this is just a random Star Wars quote I picked for no apparent reason. Just to kind of show you that these technologies ultimately work. We go from words to sentences. But ultimately, and of course, these things fail, right? So sometimes we find mappings that are not the ones we want. And sometimes these things don't work for languages that we have less data for. But ultimately, we're seeing great amount of success in these sorts of technologies. And ultimately, but I do want to make one kind of point. I want to get back to this notion of storytelling, which is that these are kind of one-shot translations. These are one-shot deals. I can go from word to word and sentence to sentence. But stories involve long, coherent sequences of sentences. So now let's look at the challenge of storytelling. Okay? So here's a simple question. Maybe I'll ask this to you during break. What did you do for Valentine's Day? So hopefully you remember. It's only 2 days ago. And if I ask you this, you'll probably tell a story, right? Maybe you went out to a nice dinner. Maybe you went on a romantic walk, something like that. Let me tell you a story, what I did on Valentine's Day. I went to the airport and caught an airplane to Mexico City. Okay? Now let me ask you another question. Okay? You probably know what the answer to this is. How do you know? Nothing in the story I just told you had anything to do with my wife, but you can make inferences about the story because you know things about the way the world works. So this is the challenge of storytelling. We as humans use story to convey information every single day, many times a day. We use it also to entertain, to educate, to train, and so on and so forth. And then we can make inferences about the stories we tell. This is an efficient way of communicating information that people can then take and do additional reasoning and inference on. Okay, so in my work, in my research at Georgia Tech, we've been looking at a lot of what we call narrative intelligence, because narrative is a fundamental reason by which we organize, understand, and explain the world. It's about context. It's about how events, stories, sentences relate to each other over long periods of time, as opposed to a single sentence or a single word at a single time. And so what I've been trying to do is looking at, well, maybe we should try to instill computational systems with this narrative intelligence. And what can we do with that? Well, we can make computers entertain us better, train us better, teach us better, communicate with us in more natural ways. And ultimately, I think that because story is such an important aspect of the human experience, these computer systems are going to be able to talk to us better in ways that we're more familiar with. They're going to seem less alien to us. And then they're also going to understand what we tell them. They're going to understand what we do on a day-to-day basis, and they can respond to us in more naturalistic sorts of ways. So I'm just going to give you a few examples of what we might be able to do and what we're starting to be able to do once we understand context, when we understand language in terms of stories. We can do things like story understanding. So now I don't have to just say very simple things to Siri, you know, these keywords and those keywords. I can now tell it longer sequences, contextual, meaningful sequences like this. So here's a very simple story, and now computers should be able to answer questions like, did John and Sally arrive together? Okay, again, like the Valentine's example, the question has nothing to do with what's actually in the sentence, so is what we see there, but it's something that a human should be able to answer and a computer should be able to answer too. And the reason why we're able to do this is something called common sense reasoning. We understand how the world works. We understand what people do traditionally when they go to restaurants, and so we can fill in the gaps, we can fill in the missing details with what we know. Common sense is what's missing largely from artificial intelligence systems right now. They don't live in the world with us. They don't understand what we do on a day-to-day basis. We flip the coin over. The opposite side of story understanding is story generation. So now we can get computers to tell us new stories, maybe to entertain us, maybe to teach us. maybe to help us understand the world through news and journalism and so on and so forth. This is a story that was generated by one of my systems about a boy and a girl who go on a date. I'm pretty happy with this. I think you'll see that all the things that happen in a date kind of happen in the right order. The really cool thing here is my computer learned what a kiss is. That you're supposed to, well, first of all, it learned that you should hold hands before you try to go for that kiss. So for the guys out there, okay, try this, all right? So now you've learned something from an artificial intelligence today. Okay, stories convey meaning and complex emotions in humans. So here's one of the shortest stories in the world. Can we understand why this has an effect on humans? And if so, can we engage people in new ways? Or we could do automated journalism in the sense that can we take people on a journey through a particular story? And then also explanation. We use stories to explain what we're doing. Why did you do that? How did you do that? So on and so forth. This is a very simple system of an AI that's playing Frogger. It uses a technique called Q-learning. You probably don't know what Q-learning is. It's a very mathematically based way of solving a problem or playing a game. What our system is doing here is it's translating Q-learning into natural language. So it's actually explaining things in the way that we'd actually feel comfortable understanding. It actually watched people play Frogger and talk out loud while they played Frogger, and it learned to emulate their language as it's playing along here. And I think watching what's happening here is a very reasonable way of understanding what it's thinking about as it's trying to play this particular game. What I think is one of the most interesting and useful applications of computational narrative intelligence is what I call machine enculturation. So in the near future, we're going to see robots and artificial intelligences come into our world. They're going to be healthcare providers. They're going to be they're going to help us do our chores. They're going to follow us around in the real world. And as they go out into the real world, there's the potential for conflict. They're going to come into contact with us. They're going to rub elbows with us. They're going to get in our way and interfere with us, but also help us as well. So it makes sense that robots, when they go out into the real world, are going to have to understand the social conventions. They're going to understand how our cultures, how our societies work, and how we move around in the environment and how we interact with each other. And you might think, well, I haven't seen these robots out there. We're still pretty far off. But in fact, we're all carrying artificial intelligences in our pocket at this very moment. They're called sometimes Siri or Cortana or sometimes Alexa. And you might think, what possible trouble could an artificial intelligence that's in my pocket get into? And well, last year we did actually see an example of this. A web chatbot called Microsoft Tay, released by Microsoft, learned over time to say progressively more racist and sexist sorts of things. And it was shut down before it ever got to the point where it was saying things that made people upset enough to harm themselves or harm someone else. But you can actually kind of see where even language can get us into a lot of trouble. And one of the reasons why Microsoft Tay was a failure was because it didn't understand that there are times where you say certain things and there's certain things you don't say to people. There were social contexts, there were social conventions that were being violated by the system because it didn't understand culture. So how do we teach computers about human values, about how our society works, the rules of culture? The hypothesis I'm looking into is that we can learn this information by reading stories. We can get artificial intelligence to read stories that have been written about our own cultures. So it turns out when authors write stories, they encode their implicit biases, their implicit understanding of how the world works into the characters they're writing about. So you can see this in allegorical tales and fables, which are usually explicitly telling us the values of society. But you can also even look at contemporary literature. And you can find anything from examples of what people do at coffee shops to more moralistic sorts of things. Good guys never steal, bad guys break the law, those sorts of things. And as we can learn these particular rules and values of society, if we can mine these out of language, of the stories that humans write, what we're basically doing is we're saying, well, artificial intelligence can learn how our society works and our cultures work. And if they can do that, they can avoid conflict. Because ultimately, social conventions exist so that humans, when they rub elbows, don't end up in conflict. Right? It's everything from standing in line while you're waiting in a restaurant to the social protocols we do when we greet each other on the street. Right? So as the robots begin to follow social rules, they will become safer. They will not antagonize us. They will not get in our ways in the same way. They will be polite, for example. So I'm going to end here with a few concluding thoughts. I do believe that this notion of computational narrative intelligence is going to provide a lot of practical reasons. There's a lot of reasons why we want computers to understand, to read, and talk about stories. And it's not about taking the jobs from authors. authors are always going to be valued. We're always going to value the human component. But there are lots of small little reasons, everyday social interactions that involve storytelling, either us telling stories to computers to convey how we want things to work, versus having them explain themselves into computers, that are going to make these computers feel less alien to us. They're going to feel like they're one of us, that we can relate to it, we can work with it, that there's something that we don't have to fear about it. And they're going to understand us as well. They can say, all right, I can infer what you're doing. I'm going to figure out what you're trying to do. I'm going to be one step ahead of you, and I'm going to be a helper and a friend along those lines. And ultimately, maybe in doing all that, robots will be more integral part of our society. They'll be safer, and they'll be kind of part of our culture, part of our society. So I'm going to leave it with that. Hopefully that kind of sets the stage for the next things that are happening here, and I look forward to talking to many of you during the breaks throughout this afternoon. Thank you very much.